Good day, ladies and gentlemen. Welcome to Code Switching 2020. Today I want us to deal with trigonometry, the basics that you must know for you to be able to solve any trigonometric equation that you are given. So I'll start from the beginning. The beginning is, if you are given a Cartesian plane, if you are given any Cartesian plane like this, in our Cartesian plane you are given a point so let's say this is point P. Our Cartesian plane has the y-axis and the x-axis. So if this is 0, the coordinate of P is given by x and y. So if this is point P, a point P will form a right angle triangle. Our right angle triangle have 90 degrees with the x-axis. So here we have the x value and the y value, and our shortest distance is given by r. So when we use trigonometric definition, we use what we call SOHCAHTOA. It's SOHCAHTOA. So, which is the sine of theta. Theta is given at this angle, which is an acute angle. The sine of theta is given by the opposite over the hypotenuse. The opposite over the hypotenuse side. The opposite is the side opposite theta. The hypotenuse is the side that is opposite 90 degrees, and it's always the longest side. So in terms of our diagram, the sine of theta will be given by opposite, which is y over r. The second part is the cos of theta. The cos of theta is given by the adjacent over the hypotenuse. The adjacent over the hypotenuse. The adjacent is the side closer to theta. So the side closer to theta, it's x over r. Then we have the tan of theta. The tan of theta is equals to opposite over the adjacent side. As we have discussed, that opposite is opposite theta. In terms of our diagram, it's y over adjacent is the side closer to theta, it's x. So the tan of theta is y over x. So we have the reciprocal of sine, cos, and tan. The reciprocal is the cosec. The cosec of theta. The cosec of theta is the same as 1 over the sine of theta. And 1 over the sine of theta on our diagram, it will be the same as 1 over sine theta. We said it's y over r. So meaning the cosec of theta will be given by r over y. Then we have the reciprocal of sec of theta is given by 1 over cos of theta. Cos of theta in our diagram, it was given by, meaning the cosec of theta will be 1 over cos, which is x over r. Then 1 over x over y, it's r over x. X over r, not x over y. So cosec of theta is the same as r over x. The last part is cot of theta. Cot of theta is the same as 1 over the tan of theta. In terms of our diagram, tan of theta was y over x, meaning 1 over y over x. Cot of theta will be x over y. So if you don't understand how you got r over x or r over y or x over y, you must say this is 1 divided by x over y. Then to change the division sign, remember we introduce multiplication. This is 1 multiplied by y over x, which is y over x. So in all the reciprocal, you do the same method. You change the division into multiplication. Then you get y over x, r over x, and r over y. So this is the first basic that you must know. After we talked about the reciprocal, remember every time when you see the tan of theta must be changed into the sine of theta over the cos of theta. And every time when you see the cot of theta, it must be changed into cos of theta over the sine of theta. Every time when they say simplify or reduce, when you see tan, you simplify it into sine over cos. Cot, you change it into cos over sine. Then we have the square formulas. The square formula says the sine squared of theta plus cos squared of theta equals to 1. So meaning when you see 1, you can change it into sine squared theta plus cos squared theta. Theta can be any angle. So again, when we transpose cos squared theta to the right hand side, meaning every time we see sine squared theta, we can change it into 1 minus cos squared theta. Or every time when we see cos squared theta, we can change it into 1 minus sine squared theta. So again, from our square formula, we had sine squared theta plus cos squared theta equals to 1. When we divide both sides by sine squared theta, sine squared theta, sine squared theta. Sine squared theta over sine squared theta, it's 1 plus cos squared theta over sine squared theta. Remember, cos over sine is cot. This is the same as cot squared theta. Will be equals to 1 over sine was cosec. If it's squared, it will be cosec squared theta. This is another identity that is important to know. So if the first time we divided by sine, what happens if now we divide each term by cos? from the same identity, it will be sine squared theta plus cos squared theta equals to 1. Divide both sides by cos squared theta, cos squared theta, cos squared theta. Sine squared theta over cos squared theta, sine over cos is the same as tan squared theta, plus cos squared theta divided by cos squared theta, it's 1, will be equal to 1 over cos squared theta. 1 over cos is the same as sec. If it is squared, it becomes sec squared theta. This is another identity. So most cases when you talk about general solutions, when they say simplify, when you see cosec squared theta, you can change it into 1 plus cos squared theta. Or when you see sec squared theta, you can change it into tan squared theta plus 1. So the same applies when you see 1 plus cos squared theta, you can change it into cos sec squared theta. That's the square formulas that you must know. So now let's move to the 4 quadrants. In trigonometry, we have 4 quadrants. We have our 4 quadrants. Our quadrant, we have quadrant number 1, where it's from 0 to 90 degrees. From 90 to 180, we have quadrant number 2. From 180 to 270, we have quadrant number 3. And from 270 to 360, we have quadrant number 4. So we call this the cast diagram. On the first quadrant, all trig ratios are positive. On quadrant number 2, it's only the sign that is positive. On quadrant number 3, it's only the tan that is positive. On quadrant number 4, it's only the cos of theta that is positive. So from our 4 quadrant, we have what we call the reduction formula. And it is important to know the reduction formula because of it helps us to simplify other equations that we are given. The reduction formula states the following. It says that any function of 180 plus minus theta can be written as the same function of theta. It's 180 plus minus theta or 360 plus minus theta. So this can be written as a function of theta. Okay, I'll explain more on the reduction formula part. So what are they saying? They are saying that when you see, for example, the sine of 180 plus theta, what you need to check again is that which quadrant are you looking at? Is that function positive or negative? Remember, on quadrant number 1, we have 90 minus theta, and we also have theta minus 360 when you go in terms of negative angles. Then quadrant number 2, we have 90 plus theta, or we have theta minus 270. You also have 180 minus theta. So quadrant number 3, we have theta minus 180, or we have 180 plus theta. Quadrant number 4, we have negative theta, or we have 360 minus theta. So when we go anti-clockwise, you have 90 minus theta, 90 plus theta, 180 minus theta. On quadrant number 3, you have 180 plus theta, 360 minus theta. We also have 360 plus theta when we go clockwise. But when we go anti-clockwise, this is when we went anti-clockwise, my apology. When we go clockwise is this way. That's where we start to have the negative angles. This is clockwise. We have negative theta, theta minus 180, theta minus 270, and theta minus 360. So what are they saying? They are saying that when you see 90 minus theta, you must know that we are referring to quadrant number 1. When you see theta minus 360, you must know that we are referring to quadrant number 1. This is when we're going anti-clockwise again. So this 180 minus 180 plus, they are talking, or they are referring to the quadrants. So when we come to reduction formula, we are saying when you see 180 plus theta, you must check which quadrant is this. Is quadrant number 3. Then is sign positive or negative? Sign is negative. So since we said that 180 plus theta can be written as a function of theta, this will be the same as negative, because of sign is negative on the 3rd quadrant. This will be negative the sign of theta. Again, what happens now when you are given the sign of theta minus 180? Which quadrant is theta minus 180? When we look at our cast diagram, theta minus 180 is quadrant number 3, and sign is also negative. So this will be negative the sign of theta. What happens now when you are given the tan of 360 minus theta? Which quadrant is 360 minus theta? 360 minus theta is quadrant number 4, and tan is negative. So this will be the same as negative the tan of theta. Okay? Then what happens now when you are given values? For example, they will say, what is the sign of 180 minus 45? 45 is our theta. 180 minus any theta is quadrant number 2. And in quadrant number 2, sign is positive. So this will be positive the sign of 45. I hope it makes sense in terms of the reduction formula. So we also have cofunctions. cofunctions. The cofunction is when we see 90 plus minus theta and 270 plus minus theta. So it says any function of 90 plus minus theta or 270 plus minus theta can be written as the cofunction of theta. What are the cofunctions? The cofunction of the sine of theta is cos theta. The cofunction of tan theta is cot theta. And the cofunction of sec theta is cos sec theta. And remember, you still also need to check which quadrant is that function, positive or negative. For example, in terms of cofunctions, when you are given the cos of 90 minus theta, when you see 90, what must come to mind is cofunction. When you see 180 or 360, it must come the reduction formula. So when you are given the cos of 90 minus theta, what is the cofunction of cos? It's sine. Then we check the quadrant. 90 minus theta is which quadrant? Is quadrant number 1. So if cos is positive on quadrant number 1, also its cofunction must be positive. So the cos of 90 minus theta can be written as its cofunction, which is the sine of theta. Again, if we have the cos of 90 minus 27, when we see 90 minus any theta, we must think about the cofunction of cos. So meaning the cofunction of cos is sine, and 90 minus theta is quadrant number 1. All trig functions are positive, so this will be the same as the sine of 27. What happens now when we are given cosec of 90 minus 20? What is the cofunction of cosec? It's sec. 90 minus 20 is quadrant number 1. And cosec is positive, also its cofunction will be positive. So this can be written as sec of 20. So what happens now when we are given the tan of 90 plus 40? You check on our quadrant. 90 plus any theta is quadrant number 2. So in quadrant number 2, the only trig ratio that is positive is sine. So, but where we see 90 plus minus theta, we can write this function as its cofunction. The cofunction of tan we said is cot. So this is the same as cot of 40. But again, is tan positive on quadrant number 2? No. Also its cofunction must be negative. So this is negative the cot of 40. So what if now we have sec 90 minus 30? Sec is the same as 1 over cos. 90 minus 30 is the first quadrant. All trig ratios are positive. So what is the cofunction of sec? Is cosec. So this can be written as cosec of 30. So please keep in mind, remember the cofunction and the reduction formula. every time when you are given to say simplify, and also remember the quadrants as well. It's very important. Okay? Again, they will ask you to say simplify without using a calculator. Every time when they say simplify without using a calculator, remember the trig ratios. If we can express each function as the trig ratios, the trig ratios are 30, 45, 60. We get our trig ratios from the right angle triangle. This is our right angle triangle. The first triangle is where we get 60 degrees, 30 degrees. This was created from an equilateral triangle of length 2, and this was cut to half. We got 1. When we use Pythagoras, we get the square root of 3 to calculate the opposite side. So the other trig ratios, we get it from a square, but we create a right angle with the diagonal. Then each angle is 45, and we have the right angle here. This side we get 45. It was from a square with the length of 1 and 1, and the longest side is the square root of 2. So our trig ratios are important because of when we say without using a calculator, you must know that when you got the sine of 30, the sine of 30, sine of theta is opposite over the hypotenuse. So this is opposite. The hypotenuse is the longest side, meaning the sine of theta will be 1 over 2. The sine of 60 is still opposite, but the opposite of 60 is the square root of 2. Is the square root of 3. This will be the square root of 3 over the hypotenuse, which is 2. The same when they say the sine of 45. The sine of 45, any 45 that you are looking at, from this one example will be opposite, which is 1 over the square root of 2. And since you are not allowed to have the square root as the denominator, we rationalize the denominator by having the square root of 2 over the square root of 2. 1 multiplied by the square root of 2 is the square root of 2 over the square root of 2 multiplied by the square root of 2 is 2. So, for practice purposes, please try without using a calculator to find the sine of 60. I know the sine of 60, we already did it. Please try to find the cos of 30, the cos of 45, the cos of 60, and the tan of 30, the tan of 60, and the tan of 45 without using the calculator. You just look at the diagram and remember SOHCAHTOA. Cos is the adjacent over the hypotenuse. Tan is opposite over the adjacent. Okay? So far, the work that we have covered is grade 11, and trig ratios are grade 10 stuff. So let's cover what you must know in terms of trigonometry in grade 12. In grade 12, what we need to do, the first one, is to know how to prove the compound angles. For example, they'll ask you in the exam to say, prove that the cos of A minus B will be given by the cos A cos B plus sine A sine B. You must know how to prove this one for exam purpose, but I'll also show you on the later stage how to prove it. So in grade 12, you need to know how to use compound angles. Compound angles. Compound angles, we have the compound angles of cos, sine, and tan, but tan is not used most in the exam. So for cos, it says the cos of A minus B is given by cos A cos B plus sine A sine B. So what are they saying? They are saying if you are given the cos of angle A minus B, you can expand this to say this is cos angle A cos angle B. If it's positive, if it's negative here, it changes the sign to become negative. If it was negative, becomes positive. The sine of angle A multiplied by the sine of angle B. So if they have expanded it for you already, you can change it into, if they have already expanded for you, you can change it into cos A minus B. Please be mindful of the sign for cos. For sine, compound angle does not change. So for cos, again, if you are given the cos of angle A plus B, this can be expanded into cos A cos B. If it's plus, becomes minus sine A sine B. Again, if they have expanded it for you, you can simplify it. If they need to simplify it, you can expand it again. Just be mindful of the sign in terms of cos. Another compound angle that you must know is for sine, which says the sine of angle A minus B will be equal to sine A cos B. If it's minus, for sine remains minus, minus cos A sine B. So again, for sine, we have the sine of A plus B will be given by sine A cos B. If it's plus, still plus for sine, plus cos A sine B. You must know how to use the compound angles, but it is also given on the formula sheet. So just to save time, I won't do the tan compound angles because of it's not going to be there in the exam. So from the compound angles, we get double angles. From compound angles, we get double angles. For example, when we have the sine of A plus A plus A is the same as the sine of 2A. Hence we said double angle. But remember, from our compound angle, the sine of any of the sum of the two angles. It was sine A cos B plus cos A sine B. So in terms of sine, if it's sine A plus A, it will be the same as sine A cos A plus cos A multiplied by sine A. So sine A cos A plus cos A sine A is the same as 2 sine A cos A, because the angle is the same. So if we started with sine A cos A, can be the same as sine A cos A. Then we added the like term is got 2 sine A cos A. So every time when you see the double angle of sine, you can express sine 2A as 2 sine A cos A, depending on the angle that you are given. If it's sine 2 theta, you will say 2 sine theta cos theta. That's the double angle of sine. Then we got the double angle of cos. The cos of A plus A. Remember, cos always start with cos, cos, sine, sine. So this will be the same as cos A, cos A. Remember, cos, if it's plus, changes the sign into minus, sine A, sine A. What is cos A times cos A? Is cos squared A minus sine A multiplied by sine A is the same as sine squared A. And cos A plus A is the same as cos 2A. So the double angle of cos, which is cos 2A, can be expressed as cos squared A minus sine squared A. That's the first step. But remember, because of we have cos squared and sine squared, from our square identity, we said cos squared theta. Let me express this in terms of A, the double angle. We said cos squared A plus sine squared A is equals to 1. So meaning cos squared A can be expressed as 1. I transpose sine squared A to the right hand side minus sine squared A. Or sine squared A can be expressed as 1 minus cos squared A. So if you are given, or every time when you see sine squared of any angle or cos squared of any angle, let's in this term is the angle is A, you can express this as minus 1 minus sine squared A. Sine squared A can be expressed as 1 minus cos squared A. So from our double angle of cos, where I see cos squared A, I will say this is the same as 1 minus sine squared A minus sine squared A, which is this one. So the like terms, 1 minus sine squared A minus sine squared A is the same as 1 minus 2 sine squared A. So another double angle of cos can be written as cos 2A equals 1 minus 2 sine squared A. Double angle of cos. The other double angle of cos, where I see sine squared, I will say cos of 2A is given by cos squared A minus, we said sine squared A can be expressed as 1 minus cos squared A. Because of the negative sign, you must open the brackets. This is 1 minus cos squared A. So this will be cos squared A minus 1. Negative times negative is positive cos squared A. Cos squared plus cos squared is 2 cos squared A minus 1. So another double angle of cos 2A can be written as 2 cos squared A minus 1. So meaning the double angle of cos can be written 3 different ways. So you just have to change it depending on how you want to solve the given equation. So this is the trick part that you must know in terms of solving trigonometric in grade 12. Now let's look at the questions from every concept that we have covered so far. If you may have a bit of understanding, you may pause the video in each question, try it out, then after look for the solution. But if you don't understand, it's fine. Just look at the video, then you'll do others as we proceed. Let's look at the first question. The question says simplify. We are given 2 sec 300 multiplied by cos 140 multiplied by sine 40 divided by the sine of 8. So what you must do is to apply everything that we have talked about so far. Pause the video, try it out. If you don't have any idea, it's fine. This will be the first one. So how do you simplify this one? You first check what type of angles are you given. The smallest angle that we are given is 40. So we have 80, we have 140, and we have 300. So meaning we can try to express each angle with the smallest angle of 40, for example, but we cannot express 300 in terms of 40. We'll express 300 in terms of special angles. Our special angles, remember, is 30, 45, 60. So this will be 2 the sec of 300 can be the same as 360 minus 60. Our special angle is 60. Multiply by 140 can be expressed in terms of the smallest angle, which is 40. So this will be the cos of 180 minus 40. 180 minus 40 is the same as 140. Multiply by the sine of 40. All divide by the sine of 80 is the same as sine 40 plus 40. So looking at our simplified equation, we have 360 minus. Every time when you see 360 plus minus, reduction formula. Check the quadrant again. 180 plus minus, reduction formula. 40 plus 40, compound angles. So let's simplify. Sec we said is the same as cos. So meaning sec is the same as 1 over the cos of 360 minus 60. 360 minus 60 is the fourth quadrant and cos is positive. So this will be 2 sec 60. Multiply by cos of 180 minus theta. reduction formula. 180 minus 40 is the second quadrant, and cos is negative. So you open a bracket, because of here we have multiplication. We say minus the cos of 40 multiply by the sine of 40. All divide by, remember the compound angle of sine, which is double angle. So we said the sine of 2a was the same as 2 sine a cos a. So if it's 40, it will be the same as 2 sine 40 cos 40. So the negative will multiply across. When you simplify this will be negative 2 sec 60. Let's simplify sec. Let's write it in terms of cos. This is negative 2 open bracket 1 over the cos of 60 multiply by the negative, it's here, cos 40 multiply by sine 40. All divide by 2 sine 40 cos 40. Therefore 2 will cancel out 2 because of there is multiplication. Sine 40 will cancel out sine 40. Cos 40 will cancel out cos 40. Then what are we left with? We'll be left with negative 1 over the cos of 60. Remember our special angles. Our special angles, you draw your triangle on the side, just so that you remember. We said special angles of 60 and 30 comes from an equilateral triangle of equal length of 2. This was cut into half, it's 1. Then we got the square root of 3. So what is the cos of 60? Cos, remember, is the adjacent, which is the side closer to the angle over the hypotenuse. So the cos of 60 is the same as 1 over 2. So because of this is 1, this will be equal to negative 1 divided by 1 over 2. 1 over 2 is the same as negative 2. Negative 2 is your final answer. So let's do a quick recap. First thing, when you're given an equation to simplify, you check if you can simplify this in terms of special angles or in terms of the common angle, which is the smallest angle. As I've said that our smallest angle is 40, we'll try to express everything in terms of 40. But where you see angles like 360, 360 can be expressed in terms of special angles. So 300, not 360 man, I mean 300. 300 is the same as 360 minus 60. 140 is the same as 180 minus 40. 80 can be expressed as 40 plus 40, which gives us double angle. And the double angle of sine, as we have spoken, is the same as 2 sine 40 cos 40. 360 minus 60 can be expressed as sec 60. And cos 180 minus 40 is the second quadrant, and cos is negative. So this can be written as negative the cos of 40. Then you bring the negative side, this side. Then negative 2 cancel out 2. Cos 40 cancel out cos 40. Sin 40 cancel out sin 40. You are left with 1 over the cos of 60. And cos of 60 is the same as 1 over 2. Because of we have 1 here, this becomes 1 divided by 1 over 2. We got negative 2. So let's look at the second question. The second question says, prove that sine 30 plus x plus sine 30 minus x equals to cos x. This is cos x. So again, please pause the video, try it out, and look for the solution. So remember the compound angle of sine. The compound angle of sine, we said the sine of A plus B is the same as sine A cos B. If it's plus, it becomes plus cos A sine B. So we'll expand this one first. We'll expand. So meaning this is the same as the sine of 30 multiplied by the cos of x plus the cos of 30 multiplied by the sine of x. This is the first part. Plus the second part, if it's negative for sine, if it's negative, the compound also becomes negative in the middle. So this will be the sine of 30 multiplied by the cos of x minus the cos of 30 multiplied by the sine of x. So we have, let's check if we have the like terms. Sine 30, sine 30, cos x, cos x. This is the like terms. So this will be 2 sine 30 multiplied by cos x. Let's check the second part if there are like terms. Cos 30, sine x, sine x. But the middle term, the middle sign is negative, so this will cancel out. So we see sine 30. Remember the special angles. You draw your triangle again, as always. This is 60. This is 30. It's an equilateral triangle of 2 lengths. This is 1, and this is the square root of 3. Sine is opposite over the hypotenuse. So the sine of 30 will be 1 over 2. So you substitute, you say this is 2 into 1 over 2 multiplied by the cos of x. 2 multiplied by 1 over 2, it's 1. So this is the same as the cos of x, which equals to the right hand side. You are done with number 2. Let's look at number 3. The third question, they say determine the value of sine 75 minus sine 15. Again, here they are asking us to see if we understand the compound angles. So you try to express 75 in terms of special angles. This will be the same as the sine of 75. 75 can be the same as 30 plus 45 minus sine 15 is the same as the sine of 45 minus 30. So the compound angles of sine on the first part is sine 30 cos 45. If it's plus, it's plus cos 30 multiply by sine 45 minus, let's open the brackets to expand the compound angles of sine again. This will be sine 45 cos 30 minus cos 45 the sine of 30. We are expanding the brackets because of the sine will affect each term. So when we simplify, this is the sine of 30, the cos of 45, plus the cos of 30, the sine of 45. Negative terms positive, this is minus the sine of 45, the cos of 30. Negative multiplied by negative becomes positive, the cos of 45 multiplied by the sine of 30. Then we need to check if we have the like terms. Let's highlight sine 30 cos 45 sine 30 cos 45. So this will be 2 sine 30 cos 45. The other part, cos 30 sine 45 cos 30 sine 45. But the middle term is minus. And then the 2 will cancel out. Then we are left with 2 sine 30 cos 45. Again, remember your special angles. You draw your triangle so that we don't use a calculator. This is 60. This is 30. You don't have to draw the triangle on your answer sheet. You can just draw it aside. This is 2. This is 1. This is the square root of 3. In terms of 45, it was a square with the length of 1 and 1. This is 45. 45, we have 90 degrees and the square root of 2. So when we simplify our answer, this will be 2 into the sine of 30. We said it's 1 over 2. It's 1 over 2. The cos of 45, cos is opposite over, my apology, we did a mistake here. In terms of our length is 1, 1, the square root of 2. I was surprised that the cos of 45 is giving me 1, which was incorrect. So looking at any of the angle, the cos is the adjacent over the hypotenuse. So the cos of 45 is 1 over the square root of 2, which is the same as the root 2 over 2 after we have rationalized our denominator. So this will be multiplied by root 2 over 2. 2 multiplied by 1 over 2 is 1. Your final answer is root 2 over 2, which was the same as our first answer, but in terms of the variable, it was the cos of x. So now our value is 45. Then we use special angles, which is root 2 over 2. Let's look at the second one. Number 4, they say simplify 2 tan x all divided by 1 plus tan squared x. Remember I said every time when you see tan, you must express it in terms of sine over cos. But before, remember the identity. The identity of cos squared theta plus sine square theta equals to 1 is because of I see that 1 plus tan square theta can be expressed in terms of one of the identities. Which identities are we going to talk about? It's when we divide each term by cos squared theta. Cos squared theta, cos squared theta. Cos squared theta divided by cos squared theta is 1 plus sin squared theta over cos squared theta is the same as tan squared theta. 1 over cos is cosec. If it is squared, is it's not cosec, I mean it's sec. My apology. It's sec squared theta. So meaning where I see tan 1 plus tan squared theta, I can substitute with sec squared theta. So the first step is to say this is the same as 2 tan x divided by sec squared x. Then we'll simplify. This is the same as 2 tan, remember it's sin x over cos x divided by sec, we said it's 1 over cos squared x. So we change the division sign into multiplication. This is the same as 2 sin x over cos x multiplied by cos squared x over 1. So if it's 2 tan, please don't make the mistake of saying this is 2 sin x over 2 cos x. No, the 2 remains. You just change the tan into sin x over cos x. One of the cos cancel out the cos x here. Then we are left with 2 sin x multiplied by 1 cos x. What was 2 sin x cos x in terms of your compound angles? 2 sin x cos x is the same as sin 2x. This is how you should have simplified this one. Then I'll stop the video here and continue more with other questions on the second video. Thank you for watching. For more videos, please go to Code Switch in 2020 and stay tuned for the second video. Thank you.